In this question, we are asked to find the molar specific heat of this molecule. So the molar specific heat at constant pressure, which is Cp, which we usually denote by Cp, is equals to Cv, that is the molar specific heat at constant volume, plus R, and this Cv itself is written in terms of the degrees of freedom as F by 2 R plus R. So what we need to find is the degrees of freedom of the molecule. So the degrees of freedom are basically three kinds. The first one is the translational degree of freedom, in which the whole molecule can translate, the whole molecule, that is this whole thing, can move in one of the three directions given by the x, y and z axis. X, y, z. The whole molecule can move in either direction. So we have got 3 degrees of freedom for translational. And next is rotational. Now here, if you put in the concept of the x-axis, the y-axis and the z-axis, the molecule, if it rotates around y-axis, it can go this way. That is 1 degree of freedom. The molecule, if it rotates this way, it is exactly symmetric, so we can't count this as a degree of freedom. And in the z-axis, if it rotates above the z-axis, then this thing will go first upwards and then come down the other side, which is not really symmetric, so we can count the z-axis. Which gives us the 2 degrees of freedom for rotation. It can also be considered as theta and phi, the azimuthal and polar angles. And third, we have got vibrational degree of freedom. Now, as we can see in the picture, that there are 2 bonds in which vibration can occur. This is one and this is another. In these 2 bonds, vibration can occur. So there are 2 bonds, but vibration has 2 different degrees of freedom. The kinetic degree energy gives 1 degree of freedom and potential gives another, which means in fact there are 2 kinetic and 2 potential, which means 4 degrees of freedom in the vibrational end, and therefore we end up with F equals 9. Using this F equals 9 up here gives us Cp equals 9 divided by 2 R plus R, and this is 4.5 plus R, so Cp equals 5.5. This is our solution.